Okay, so let's continue with the second video by getting to know how to open the Jupyter Notebook script. So let's begin. So as you can see here, I'm starting by opening Terminal. So Terminal is a text-based way of communicating with the computer. Instead of clicking through folders, I can give the Mac direct instructions by typing commands. The command cd, as you can see here, okay, this is cd, means change directory. A directory is simply a folder. In this case, I'm asking terminal to move inside my SQL portfolio project folder. So the folder name contains spaces, so I place it inside quotation marks. This helps terminal understand that entire phrase represents one folder name. This quotation marks basically helps terminal understand that the entire phrase represents one folder name. So once I'm inside the folder, I run the Jupyter Lab. This starts a local Jupyter server. This is a server and opens Jupyter Lab in the browser. I'll show you that exactly. Just wait a minute. I have to share the Jupyter browser. Just a minute, guys. Yep. So as you can see, this is a Jupyter browser. Now, Jupyter Labs runs on my own computer. The local host address does not mean the notebook is publicly available online. It simply means the application is running locally on this Mac. So once I type Jupyter in the terminal, this opens this Jupyter Notebook, and this is actually running on my own computer. This local host address does not mean that a notebook is publicly available online. Okay. So this local host address doesn't mean it's publicly available online. It simply means the application is running locally on this Mac. Okay. So opening this project notebook, as you can see inside Jupyter Lab, I can see all the project files stored in one folder, right? Now this is all the project files. They are stored in one folder. That is the customer churn analysis. So these include the SQLite database, the original Excel data sheet, then the reference notebook, the presentation, and my own project notebook. So these are all the files here. So I've opened the customer churn analysis and customer intelligence.ipynb. So an .ipnb file is a Jupyter notebook file, okay? Just in case you don't know. So notebook contains cell. Some cells are used for Python code. Other cells are used for Markdown, which allows us to write headings, explanations, documentations, and business commentary. And that's what we have done here. This is the Markdown. Okay. So this combination makes Jupyter useful because the complete analysis can be documented in one place, right? Now let's understand Markdown and code cells. So Jupyter Notebook has two types of cell that we will use regularly. So Markdown cell is used for written explanation. while a code cell is used for Python commands. Now, this is a Markdown cell, and this is a code cell, as you can see here. So think of Markdown as the explanation section of school notebook, while code cell is the section where the actual calculation is performed. Now, the heading and the project objective at the top are written in Markdown. The Python imports below them are written inside code cell. To run either type of cell, I use Shift plus Enter. This executes the current cell and move to the next one. Now, project heading and objectives. Now, before writing the code, I begin the notebook with a clear title and the project objective. Now, this may seem like a small step, but it is important for a professional portfolio. A recruiter, interviewer, or a stakeholder should immediately understand what the project is about, what business problem is being solved, and which technologies are being used. The objective explains that this is an OTT customer churn analysis combining SQL and Python. It also makes clear that the analysis focused on identifying churned customers, understanding churn drivers, and generating business recommendations. Now, there comes importing the required libraries. So as you can see the code, before beginning the work, I first bring the required tools into Python. Imagine that Python is an empty toolbox. So Python can perform basic operations by itself, but specialized tasks require specialized tools. So Python library is like adding a new tool to the toolbox. The word import tells Python, please load this library because I want to use its feature. First is to import SQLite 3. SQLite is the database system used in this project. The SQLite 3 Python library allows Python to open the database file, send SQL queries, and received result. It works like a translator or communication bridge between Python and SQLite. We do not use an alias for SQLite 3 because its name is already short and easy to understand. The second is import pandas at PD. Now, pandas is one of the most important Python libraries for data analysis. It allows us to work with data in rows and columns similar to an Excel table. Pandas call this structure as a data frame. I import pandas using the alias PD. An alias is simply a shorter name. Instead of typing pandas.read so dash SQL, every time I can write pd.read dash SQL. So the shorter alias keeps the code cleaner. The third is import NumPy as NP. NumPy is used for numerical calculations. It supports mathematical operations, arrays, missing values, handling, and feature engineering. So NumPy is imported using the standard alias NP. So import matplotlib.pyplot as PLT. So matplotlib is a visualization library. It allows us to create charts such as bar charts, line charts, pie charts, and scatter plots. So I'm importing the pyplot section of matplotlib. So pyplot contains the function normally used to create charts. It is imported with the alias plt. Now last is import cborn as SNS. So cborn is another data visualization library. It's built on the top of matplotlib and helps create more polished and statistically informative charts. Cborn is imported using the alias SNS dot. So why there is no output? So when I run this code cell, nothing is displayed. This is completely normal. The purpose of the cell is not to print a result. Python is simply loading the libraries into memory. If no error appears, it means the libraries were imported successfully. Now, connecting to the SQLite database. So, now I establish a connection between Python and the database. The database is stored inside a file called customer-churn.db. It's important to understand that this is not a folder and not a table. It is one SQLite database file containing multiple tables. So think of database files as cupboard. Inside the cupboard, there are several drawers. Each drawer represents a table. In this project, the drawers are DB customers, DB subscription, and DB support. So I use SQLite3.connect to open the database file. Result is stored in Python variable called con. Con is short for connection. So the con here is short for connection. Okay. The variable represents the active communication channel between Python and SQLite. Now, on the right side, Python uses connect function from the SQLite library. See here. So inside the brackets, I provide the database file name. That's customer/churn.db. Now on the left side, the result is stored in con, right? Result of this is stored in con, that's connection. The equal sign in Python does not mean mathematical equality here. It means this equal sign. It means store the item on the right side, the variable. Store the item on the right inside the variable on the left. So con is equal to sqlite3.connect.customer-churn.db means this item on the right side is stored inside the variable on the left. So because the notebook and databases are stored in the same folder, I only need to provide the file name. Okay. If the databases were stored somewhere else, I would need to provide the path. Now, it is also important to type the file name correctly. SQLite can create a new empty database when an incorrect file name is applied. Therefore, the next step is to verify that expected tables exist. Now you see this table query. With select name from SQLite master, where type, table, order by name. So this SQL query is written between three quotation marks. These are called triple quotes. They are not three colons. Triple quotes allow Python to store text across multiple lines. Without them, the complete query would normally have to be written on one line. A SQL query is therefore being stored as Python string. A string means text. So why store SQL inside a variable, you may think. So I store SQL inside a variable that is called table query. But Python does not execute the SQL immediately. It simply remembers the SQL text. Later, I will pass the queries to Panda along with database connection. Now, what does select name means? Select means retrieve information. In this case, I want to retrieve the name field. From tells SQL where to retrieve the information from. SQLite master is a special SQLite system table. It stores information about database structure. In other words, it contains metadata. So metadata means data about data. For example, it stores information about table name, views, indexes, and triggers. For the where clause applies a condition. It tells SQLite only show objects whose type is table. This prevents views, indexes, or other database objects from being included. An order by name. Order by name sorts the results alphabetically by table name. So semicolon marks at the end of the SQL statement. Here, this semicolon marks. It is optional for one query executed through Python, but using it as standard SQL practice is great, but it is optional. So now it's executing the SQL query with pandas. Now, as you can see in this, tables is equal to pd.read dash SQL to table query, comma, con table. So as a SQL query has been written, it still needs to be executed. So I use pd.read dash SQL, then bracket folds. Now, this is a Panda function that can execute a SQL query and convert the result into data frame. So it receives two things, the SQL query and the data connection. Now, coming on to pd.read SQL table query and con, right? Now, since there is no table query, I'll just hypothetically use table query. Now, con, that is connection, tells Panda which database to request it from. Panda sends the query to SQLite. SQLite executes the query and returns the result. Pandas converts that result into a data frame. Let's create a data frame TF. Now, the resulting data frame is stored in a variable called tables. The data frame does not yet contain all customer records. It only contains the name of the database tables. Now moving on to tables. Now, writing the variable name on the last line asks Jupyter to display its content. We should expect to see db.customer, db.subscription, db.support. Now, importing every SQL table into pandas. So as you can see, understanding if we price data frame is equal to close brackets, this creates an empty Python dictionary. A dictionary stores information using a key and value. Think of it like labeled cupboard. The label is the table's name. The item stored under the label is data frame. Now later we will have something like db customers is equal to customer data frame. Now understanding for loops, a for loop repeats an action. In simple terms, Python is being told going through every table name one by one. During the first round, table.enemy may represent db.customer. During the second round, it represents db.customer. During the third round, it represents db.support. Code inside the code inside the loop is executed once for each table. So letter F before the quotation mark creates an F string. And F string allows the variable to be inserted inside text. The curly bracket acts like philosopher. During the first loop, Python may create. Now during the second loop, that select from DB customer. So now I come to the third loop, that is select all from DB subscription, right? Coming on to the fourth loop, that select all from DB support. So meaning of the asterisk is for all, for everyone. Select all from DB customers means retrieve every column and every row from the customer table. Now, reading the table into pandas. Pandas execute the current SQL query through active database connection. The result is converted into database. That data frame is stored inside a database dictionary using the table names as the key. Now you see every panda data frame has a sharp property, returns two value, number of rows and the number of columns. I store those values inside the variable rows and columns. Now this is an initial quality check. It confirms that the table was imported and shows its size. Now, the imported tables are stored closely inside a dictionary. However, for convenience, I created three clearly named working data frames. That's DF customer contains new customer information. DF subscription contains subscription information. DF support combines customer support information. Profit DF stands for data frame. I use dot copy to create separate working copies. This means later cleaning steps can be performed without directly changing the original dictionary objects. As you can see, the dictionary contains table names and data frames, right? Now, dot items. So, dot items allow the loop to access both of them. During each loop, table name represents the dictionary key. Data frame represents the data frame stored under that key. Now, as you can see, what is the meaning of slash n? So slash n normally means new line, creates a blank line before each table name. This makes the output easier to read. Now you see data frame dot column retrieves the column tables. To list bracket converts them into a regular Python list. This gives us a quick view of every available field in each table. Now, as you can see here, we have used Pragma. So Pragma is like an SQLite specific command. It is used to inspect or configure information about SQLite database. It is not a normal select query. In this case, please show me how this table is structured. Now, what are the benefits and loss of Pragma table? So it benefits are it provides fields such as CID, name, type, non, nut, and drift value. So looking only at data frame columns tell us which fields were imported. Pragma goes one step deeper. It tells us how those fields are defined inside SQLite. This is important because data cleaning depends not only on the values but also on original database structure. As you can see, display is a Jupyter function that shows a data frame in the formatted side. It's often easier to read the normal print statement. Here, I display only the most useful schema fields: column name, data types, null rule, default value, and primary key indicator. Now, after the required data has been imported and the scheme has been inspected, I close the database connection. On that close as connection.close chooses the communication channel between Python and SQLite. Think of it like opening a cupboard, taking out the required files, and then closing the cupboard when the work is complete. The closing unused connection is good professional practice because it releases resources and prevents unnecessary open connections. So if more database queries are required later, the connection can simply be de-opened. Now, as you can see at this stage, I've successfully opened the project in Jupyter Lab, imported the required Python libraries, that's here, connected Python to SQLite database, identify the available tables, imported database tables into pandas and inspecting the structure. So this completes the first technical milestone of the project. The next step is data profiling and data quality assessment. Before analyzing churn, I need to inspect the actual records, identify missing or inconsistent values, verify data types, check for duplicate records, and understand how these three data sets can be combined correctly. So we will discuss that in the next video.